does weird things and it'll have a page stick or something and then she comes back and throws a page. It happens sometimes.
Gotcha.
Or I could have done it, but I don't touch these, I just hand them out to you. I don't know. All right, radical 6 times radical 12. I put plus. I don't know what that is, but I'm going to put my radical 6 from the outside, and then I'm going to change 12 to be what?
2 times 6.
6 times 2 or just 2 times 6? I don't care which. Why do I want to write 2 times 6 instead of 3 times 4? Because I see a pair of 6s, and again, I gotta simplify this puppy. If you multiply 6 times 12, you get 72. Now you gotta look at this yellow sheet to find what's the biggest number that goes into 72. If you know it, life's grand. If you don't know it, then you gotta think too hard. Okay, so a pair of 6s get to come out of jail as a what? 6. And I have radical 2. Now I get to add those two terms together. That's called work. What do you get? 9 radical 2, what we did last class period. Okay. Remember when you have a binomial squared, stupid mistake is that these two diagonals aren't going to be the same. Once you do the top left one, or the top right one, or the bottom left one, I don't even multiply the other one unless you want to check yourself. I just rewrite it. Okay, tell me what goes in these two yellow boxes. Multiply the top 2 times that binomial. 2 radical m plus 1. The 2 is outside, the m plus 1 is inside. They can't play together. You don't distribute it, you don't multiply them together. 2 is outside, radical m plus 1 is inside. Now, what goes in the other yellow box?
The same.
The exact same thing. So this is another 2 radical m plus 1. Now, what goes in the top white box? Yeah, m plus 1. Why? Because you got 2 of the m plus 1s underneath the radical house. Anytime you have a double underneath the radical house, it gets to come out and play. Mom wants to get rid of those twins. They're too noisy, they're too rowdy. I just write m plus 1. What goes in the last box?
4.
4. 2 times 2 is 4. Now what do I have? Well, these two are identical. So in the middle here, I'm going to have 4 radical m plus 1s. Then I have an m here, and I have a 1 plus 4. Can I add 1 plus 4 together? That's where that 5 comes from. Now, does it make any difference what order you write it in? Not today. By the end of the class, we're going to put it in standard form.
Where does the 5 come from?
Where did the 5 come from? This 1 plus this 4.
Oh, okay.
And do you see how my boxes sort of help you organize your data? Again, I would never do FOIL again if my life depended on it, if I were you. You want to get an A, because I think these boxes let you take breathers, let you know you got to fill in those 4 boxes. You don't care about innies, outies, last, first terms. You just got to get those 4 boxes filled in properly. With you and your partner, try that one. 4 plus, is that one there? That's,
It's on the
On the other
next, the
side.
other page again.
dang, really? No, that's not it.
Yeah, that's
Same numbers.
Oh, it is?
just doing a little switch around there.
Okay, I did a little switcheroo. Sorry, guys,
That's all.
I'm a pain in the butt. It's on the bottom of page 2 if you're confused.
Should be separated on
Remember, if a number's outside and you're multiplying it by a radical, they can't play together. Mom says, nope, one guy's inside, one guy's outside, they can't play together, you just clunk them next to each other. When they're both outside, you get to multiply them together. If they're both inside a radical, you get to multiply them together. And then you just clean up your radicals from rule number 1 that we did last week. Are my 2 yellow boxes going to be the same this time? No, they're not, because this isn't a binomial squared. So these 2 yellow boxes, the stupid mistake is you think it's going to be the same. It's not, because it's not a binomial squared.
Wouldn't that be 20 instead of 30?
4 radical 10, 3 radical 20, 4 radical 5, and then this is 3
Three.
radical 10. Where was my brain at? Okay, the white
Wait, that's three
boxes
radical
are like,
Ten.
so that's 7
Lisa and Tim.
radical 10s. Do you agree?
Mm-hmm.
All right, now these guys aren't like, so this is your next stupid mistake. They're not like. So chances are, if I wrote the curriculum for this book, I can make them so that the radicals are like. So I want to look at 20, or you can write it as 10 times 2. Can you break 10 down so that it has a 2 as a factor?
Right.
Okay, it's 2 times 5. 2 comes out as a
Two,
2, and 2 times 3 is
6.
6 radical 5 plus 4 radical 5. Do you see this?
Yeah.
There's your 10 radical 5. It's called work. You can't pick up your calculators. You gotta know what to do with these radicals, and you gotta learn how to multiply what's outside together, what's inside together, and don't do it fast like I just did and make stupid mistakes.
If you did 4 and 5, you did the same thing, right?
Okay. Go to this slide. We don't know where this one is. Go to the slide.
Oh, no.
Keep going where it says rationalize the denominator. You know why I did this? Because I had too many slides and I wanted to give you time to do your quiz. So I got 15 minutes to do the last one. Okay. It says rule 3. Keep going. Rule 3. Keep going. Rule 3. You're good. Rule 3. Rule 3. Everybody there? Keep going. Rule 3. I just didn't want to do 15 problems and then we run out of time and then you got to stay after to do your quiz. So I just skipped those extra practice, but I'll be happy to stay after if you want to do them together. Okay, rule number 1 is dealing with this sheet. Y'all agree? Can't have any perfect square factors, cubes, fourth powers, whatever the index is, underneath that radical. Agree? That was last class. Rule number 2 says you can't have a 2-story radical house. Got to make them into 2 condos. Agree? Rule number 3 looks like rule number 2. Because do you see how you have two radical condos as a fraction? Guess what rule number 3 says? Rule number 3 says you can't have a radical in the denominator. In other words, you can't have a condo on the first floor. Why? Because you live in Florida and a hurricane's coming and the water will come in. So rule number 3 says nobody can be on the first floor because you're gonna get in trouble with the hurricane. Isn't it weird how I remember these rules, but I just do something in your everyday life to try to help you remember. So, I look up here, I see radical 20, and I go, oh, that's got some problems. It has rule number 1 in there, 4 times 5. So I know I gotta clean that puppy up. But I look down below and I say, oh, for my homework last night, this number that was in the radical house was always a perfect square on your homework. Did you notice that? It was always on that yellow sheet, because I hadn't gone over rule number 3. Rule number 3 says radical 7's on the bottom, and rule number 3 says you can't have a house on the first floor of a 2-story condo apartment. The water's gonna come in. So what do I have to do? It's called rationalize, circle that word, rationalize your denominator. This is a piece of cake. The easiest thing I'll teach you. You look at the bottom and you repeat it, maybe. Let's try it again. Twice. Why? Who invented this? Why did they have me repeat the bottom condo twice? Once on the top, once on the bottom.
Because you get rid of fractions.
It's a form of 1, isn't it? It's like saying 3 over 3, 4 over 4, 5 over 5. This just reduces to 1, so I'm just multiplying it by a funky form of 1. But why did I pick radical 7 instead of radical 8? Yeah.
Cancel out the radical.
Yeah, the radical goes away, because you got a set of twins.
Okay.
Come on, rule number 3, how hard is this? Whatever the bottom radical is, you write it on top and bottom. And when you go to simplify it, this always turns out to be whatever's underneath the radical. Come on, you guys, this is a piece of cake. Now all I have to do is clean up my top. Radical 20, does it have any perfect square factors? Well, this is your homework from last night. What goes into 20? 4 and 5. How do you get that? You gotta look on your yellow sheet and try to find a number less than 20 that will divide into it. Are they gonna give you one? Yeah, because they want you to do some extra work. So this is, look at what they do in the book. They multiply 20 times 70. Now you got a great big huge number. Ugh. I don't do that. I write it as square root of 20 times 7. And now I want to look at just 20 and see, can I break that down? Well, 20 is 4 times 5. Look at the work I'm always writing on my paper. All those 3 kids are underneath the radical house. Mr. 4, Mr. 5, and Mr. 7 are all inside playing. And again, the caretaker, the child caretaker is saying, get some of these kids out of the house. If you're a twin, get out.
Right here.
Or as a twin, it comes out as a 2. So this guy here is 2. And who's left inside playing?
That's 5.
Well, again, the numbers are so easy. If you don't multiply them together and you just write the 2 numbers that are underneath your radical house, I think it's much easier. I don't like picking up my calculator. It takes time to turn it on, clear it, and then, do some guessing and checking. I just keep these numbers small like this, and then I break down the bigger of the two numbers. So your answer is 2 radical 35 over 7, you're done. That is a perfect radical answer that you'll get 100% on. If you left it as square root of 140 over 7, you cannot divide the 7 into the 140 because one is outside, one is inside. The two never play together. We done?
No.
We got examples.
No. Okay. Now let's do a hard one. You ready? The cube root of a fraction, 5/6, you go, Rule number 2 says no two-story houses. How many times do I have to say that before it gets into your brain? So what did I do? Good. What did I do first? I put them each in their own condos. Phew. Now I gotta look at my bottom condo and say, oh, do I have a condo down there? Hurricane, what's the big hurricane that came? Katrina is coming. I gotta get those people out of that radical house. But this is a cube house, it's not a square house. So my caretaker doesn't want twins underneath the radical. What does it want? Triplets. I gotta get 3 of them. So now my form of 1, look, is 2 more 6s. Do you see that? 2 more 6s. Why? Because I have a red 6 and 2 blue 6s underneath the radical house. Can they now run away from the radical house? Can they get outside?
Yes.
Yes? Are you with me? So do you see where this 6 comes from? Now I don't have a bad radical underneath, but on top I have 5 times 6 cubed. Now there's 2 6s, but I need 3. It's never gonna happen. So I just multiply 36 times 5, that's where I get my 180. The 180 divided by 6 cannot be simplified or reduced because you never touch a kid inside a house with a kid outside of a house, ever. Okay, tell me what my rationalizing form of 1 is going to be here.
What was the question, sorry?
What's my form of 1 I need here to get rid of this cube root of 4x? There's 2 possible answers. I'll give you the easy one first. It's going to be a cube root again, right? And you could put 4 squared and x squared. And I do have 3 4z's and I have 3 x's underneath radical houses. Do you agree? Do you agree? I have 1 here. Here's 2 more. They're all underneath the radical caretaker's house. So I get 1 here plus 2 here. That gives me 3 of them in the radical house, and so the 4 comes out to play. Now I got 1 x underneath. How many more do I need?
2.
2 more. Now I have 1x, 2x, 3x. It gets to come out of the radical houses just in that. Now I gotta go to the top, but I gotta multiply the top by the same thing. So there's your form of 1. So they're both cube roots. Now I have a 3 times 16. Oh, what's 3 times 16? 48. Ooh, 48. 48. Mm. Radical 48. And I have an x to the 2. That's on top. And on the bottom I have a 4x. Do you agree? Is 48 have any perfect square factors? Go look on your yellow sheet. I don't know. But what did I do instead? I took the 4 squared and I multiplied it by 3. This is 16 times 2, do you agree? 16 times 3, sorry. 16 times 3. Does 16 have any perfect cubes in it?
Or I mean, yeah.
You mean just
Perfect-
48?
Oh, not perfect cubes, but perfect square, okay.
8, right? 8 times 2, and 8 is on my cube list.
48, yes.
So 48 is 8 times 6. Do you agree? Do you agree?
Yes.
Look on your cube line on the yellow sheet. Is 8 down there? What's the cube root of 8? 2. So I'm going to pull out a 2 cube root of 6x squared all over 2x. Are we okay? Are we okay? You gotta talk to me.
Where did you switch?
2x comes from here. When I rationalize my denominator, if you do it right, whatever's in yellow gets to come out and play.
Oh, okay, yes.
Your goal is to get Mr. 4x out of that radical house because hurricane whatever is coming.
How did the 4x turn into a 2x?
I'm getting it.
Oh.
All right. So, oh, it's all over, oh, this is a 4x, sorry. It's all over 4x.
There we are.
Now what do I have to do? What else do I have to do?
Reduce.
Shut my phone up.
Reduce.
Reduce. Why didn't it stop? It stopped on my watch. Sorry. Okay. All right, so what do I do last? I can reduce the 2 over the 4 gives me 2. So I have a 2x on the bottom, cube root of 6x squared, done. Okay. What did I do on each step? Here's the original problem in black. This is so typical of the problem I'm going to give you. So the problem in black is what you're going to get for homework. What did I do on the first step? This is called work.
Separate the houses.
Yeah.
Condos.
Break up your 2-story house, and we don't want fractions. So this is rule number 3. Or rule number 2. Rule number 2. You don't want fractions. Now what did I do on the next step to get to the next step?
FCD. No, FCD.
You're factoring.
Huh?
You're factoring.
Yeah, I'm just cleaning up
Rationalize,
the top
rationalize.
part, I'm cleaning up the bottom part. The top part here is 100 times 2, do you agree? And I can pull out some k's, do you agree?
Mm-hmm.
All right, so I pull out the 100 and it becomes a 10. I pull out the k to the 6th and it becomes a k to the 3rd, do you agree? But what else have I done that I didn't show you? Well, I cleaned up the bottom here and that's y to the third times square root of y. Do you agree?
That's good.
And then I'm going to multiply the top and the bottom here by radical y over radical y, because I want to get rid of it. Right here. You see that? I have my radical y, and I gotta get rid of the radical y, because we can't have a radical in the bottom. So I multiply the top and the bottom by this form of 1. When you have a pair of y's inside, what does it come out as?
Why?
Y. Y times y to the third gives me y to the fourth. On top, 2 and the y are both in a radical, so that stays in the radical, and the 10y to the third stays outside. Called work. Okay, next one, you gotta do conjugates. Say the word conjugate.
Conjugate.
A conjugate are two binomials, one's a plus and one's a minus. Have we already gone over these? Yes. X plus 2, x minus 2 are called conjugates. We have conjugates with radicals too. Look, here is one binomial, here's its conjugate. What's cool about radicals with conjugates is that you eliminate all your radical signs. Because remember, the diagonals are always going to cancel out, do you agree? And when I multiply 4 times 4, I get 16. And when I multiply radical 5 times negative radical 5, it comes out as a negative 5. And so conjugates will always leave us with 2 integers. No radical houses. Now, why do we need to know that? Let's go to the next slide. And we'll show you. Do you see this problem in the black box? Yes? Do you see on the bottom where I have 2 terms? When you have 2 terms and you have to rationalize the denominator, we can't write it in a form of one of exactly the same yellow blob. I have to do radical 2 minus 1, radical 2 minus 1. This has to be a minus to be the opposite of that yellow blob. When you do that, watch, the yellow terms cancel out. The diagonal terms will always cancel out. So all you have to do to get your bottom number is multiply these 2 things together, with radical 2 times radical 2. 2. Radical 4, which comes out as a 2. So it's a 2. And what's 1 times neg 1?
0.
Neg 1. Don't add them, we're multiplying. 1 times negative 1 is neg 1. Now, what's 2 take away 1? 1. I don't have any radicals in the denominator. But what do I have to do on top? I have to distribute this times each of the terms in my binomial. 1 times radical 2 is radical 2. 1 times negative 1 is neg 1. There's your final answer, or you can just write it as radical 2 minus 1. What's my conjugate here?
Plus.
Has to be a plus. So the work you're going to do is radical x plus radical 2, radical x plus radical 2. I always clean up the bottom first, because that one, I don't have to show a lot of work. You're going to multiply these 2 together. what do you get?
X.
Just x. Radical x times radical x. Anytime you have a set of twins, it comes out as just what's underneath the radical. So the bottom's gonna have an x, and then it's gonna always be a minus. Radical 2 times radical 2 comes out as
-2.
minus 2, or just 2, if you already put your minus sign. Now my denominator has an x minus 2. I'm good. But what do I have to do on top?
Distribute.
You gotta do FOIL, or you gotta do the box method, because you have 2 terms times 2 terms. So I'm gonna come over here and put radical x plus radical 2, radical x plus radical 2. And I'm gonna multiply these guys all together. Radical x times the radical x, what do you get?
X.
Just an x. Anytime the insides of the radicals are identical, just comes out as whatever it is. I have a radical x times a radical 2. Multiply, what do you get?
2x. Radical 2x.
Radical 2x. Multiply radical 2 times radical x. What do you get?
Radical 2x.
Radical 2x. The diagonals are going to be the same because this is a binomial squared. These are identical. So these two better be the same. Radical 2 times radical 2 comes out as a 2. I always combine, look at these two first. I have an x and I have a plus 2. Now how many of these radical 2x's do I have? I got one here and one here. How many do you have?
2.
Plus 2 radical 2x. That's your answer. You can't combine this 2 with this 2. You can't combine this 2x with this x because this is the coefficient of the radical. This is just the number 2. They can't be added together. They can't be subtracted together. Okay. Yep.
Wait, never mind.
Okay. The last one, you have to be careful. Look at the red problem. Do you see the green dots? When you're going to reduce, if it says divide and you want to reduce this number that's outside of a radical, this number that's outside of a radical, and then that number down below. Look, we've already done this. Watch. If I give you 6x plus 8y, and we did divided by 2. Do you remember this? It was when we were dividing with exponents, and you had to divide the 2 into the first term, and then you did the 2 into the next term. Do you remember that? You got to divide 2 into both of these pieces. You got to do the same thing with radicals. But if the number down below is outside of a radical, you can only reduce it with numbers outside of a radical up above. So what number goes into 16 and 24? I'm just reducing that fraction. What's the biggest number that goes into 16? 8, right? Or 16, but 16 won't go into 24. So 8 goes into 16 how many times? Or 8 goes into 16 how many times?
Twice.
You get it